Everyone, I'm Luca. For those that don't know me, I do research at L2Beat. What we do at L2Beat is risk assessments of rollups and L2s. We maintain, for example, the stages framework that you might have heard of, like, projects. There are different projects. There are stage 0, stage 1, or stage 2, based on their decentralization. So I spend a lot of time checking what's actually going on in the systems and exposing the trust assumptions that those systems have or the trust issues. And recently I've started working with native rollups, for native rollups, which is a way to integrate these rollups better inside Ethereum, and I'm gonna explain why in a second. Which is also kind of the next step that I see for rollups in terms of decentralization and security. But first, before talking about native rollups, I kind of want to explain why we have rollups in the first place and why we need them even in the future, right? So today, this is kind of what is going on in Ethereum. We have Ethereum itself that is kind of slow. It does 20 TPS, which is pretty bad if you look at the competitors. But then we have this series of rollups, which in aggregate do 380 TPS, these are the latest values, and if you check, this is kind of at the limit of what Ethereum can support in terms of data availability. All these rollups, they need to post data to Ethereum, and they are capped by the capacity in which that Ethereum supports in terms of data throughput, right? So Ethereum is low, and these rollups are faster, but why are they faster? We need to understand where does this scaling comes from, right? And if you look at the details, Ethereum is low because we want full nodes to be able to verify all the transactions, to verify all the state transitions. And to do so for Ethereum, you need to re-execute all the transactions. So Ethereum is artificially capped to be slow because we want nodes to be able to re-execute the transactions. Rollups are fast because to verify that what they do is correct, you don't need to re-execute all the transactions in the rollups. You can verify a ZK proof for the ZK rollups, or there is a fraud proof system for optimistic rollups, or in general, there is some sort of proof system that allows you to verify that what they do is correct without having to re-execute everything. So they kind of make use of this asymmetry between execution and verification that Ethereum right now doesn't use. But in principle, we could use the same technology for Ethereum itself, right? So let's imagine that Ethereum also uses ZK. And this is, by the way, planned for Ethereum. There is a team at Ethereum Foundation working on the ZK L1 upgrade, which is to use the ZK technology for L1 itself, right? So now, if Ethereum is also using ZK, and let's say also the rollups are using ZK to simplify, because also all the optimistic rollups are planning to use ZK anyway. So let's simplify this, and let's say that everyone is using ZK. Now Ethereum itself can also tap into this data availability. And now again, the data availability limit is, if you do the math, is around 380 TPS. So now both Ethereum and the rollups can tap into this capacity. But still, the limit is 380 TPS. But the good news is, this is today's limit, but on December 3rd of this year, there will be the Fusaka upgrade, which introduces blob sharding, which is a way to, I will not go into the details because it's very technical, but it's a way to basically distribute data so that each node doesn't need to download everything, but just a small portion of it, but in a way that this preserves the security. And this, this one will not increase the capacity immediately, but 1 week later, so on December 10, the DL limit will be bumped, based on if everything goes okay, with the network. It will be bumped to support to 525 TPS, and 1 week later, there will be another bump. So by the end of the year, Ethereum will be able to support 817 TPS. But the thing is, the goal of this Fusaka upgrade is not 800, but it's on the magnitude of around 3,000, 4,000 TPS. This is what is projected to be able to be supported with the Fusaka upgrade. And at the limit, if you, for example, look at other chains that are working on data availability, one example is Celestia, or you can look at Layer as another example. What they're aiming towards is 1 gigabyte per second. They want to have enough data availability capacity to be able to support 1 gigabyte per second. And if you do the math again, this is like a linear function. Ethereum, in principle, in the future, will be able to support 5 to 6 million TPS in terms of data availability capacity. And if you look at the diagram that I did previously, we kind of believe that the capacity for an execution environment that is atomic and like serial, that does serial execution, is 10,000 TPS. Like the EVM cannot do more, like realistically cannot do more than 10,000 or maybe 100,000 TPS. There is like one order of magnitude of uncertainty here. But the thing is, Ethereum, like the data availability throughput, will be much higher than this value, that's what a single chain can support, which is 10,000 TPS. And the idea here is to consume all this spare capacity, we need chains that run in parallel, that do asynchronous execution, and that's why we want rollups, right? So ideally, we would have Ethereum that does 10,000 TPS with the ZK upgrade, and then ideally, we would have 1,000 rollups that do 10,000 TPS each. So 1,000 rollups that do 10,000 TPS each, is a total of 10 million TPS potentially. And the thing is that if you look at rollups today, they're not amazing. They're not amazing because this is a screenshot from the L2Bit website. We have this stages thingy, and stages are, as I said before, something that indicates how decentralized the system is. If you're stage 0, you're basically centralized. You're controlled by a multisig or like some centralized operator. If you're stage 1, you're a little bit better. And if you're stage 2, you're fully decentralized. And as you can see here, all the top chains, none of them is stage 2. All of them have some sort of multisig that can upgrade the system, that can potentially rug funds. So a lot of people have been very critical about rollups because they are supposed to be an extension of Ethereum. They're supposed to inherit Ethereum security. In practice, this is not happening. Or like, there are some projects here that are trying really hard, but one of the reasons that this is not happening is because it's very difficult to do so as well. And yeah, like this is the problem of existing rollups. So we need to really understand why these projects haven't been able to decentralize. And there are 2 reasons. The first reason is that proof systems are extremely complex and therefore buggy. Like if you look inside of those smart contracts, of those ZK rollups, it is extremely complicated. There is an extremely complicated infrastructure to support the proof system. And the tech is very new, and all these systems want to have security councils, which are basically multisigs, fancy multisigs, that are there to be able to perform emergency upgrades if there are bugs. And in the past, we have seen bugs. We've seen 1 bug every month, maybe. So these systems are buggy. So that's one problem that goes against decentralization. And the other one is that especially those EVM projects, they want to be able to maintain feature parity with Ethereum, which means if Ethereum upgrades, also these rollups want to have the same features and upgrade as well. So for example, in Ethereum, there was recently 7702, which was this feature that adds some account abstraction capabilities to Ethereum. All the rollups wanted to have this feature as well, so they had to upgrade. But if a system can upgrade, it can upgrade arbitrarily. Nothing forces the systems to upgrade only to other things that Ethereum adds. They could upgrade to steal the money in the system itself. So this is a problem. So again, there are 2 reasons why they want to have multisigs: 1 to protect from bugs, and 1 to maintain feature parity. So that's why right now I'm working on native rollups. Native rollups are kind of trying to solve these 2 problems to try to get rid of these multisigs. So let's assume that L1 has performed the ZK upgrade. This is something that will happen maybe in 1 year, 2 years or so. If L1 itself can already verify ZK proofs of the Ethereum execution, of the Ethereum state transition function, we can expose an instruction within the EVM, within Ethereum itself, that reuses the ZK verifiers to be used for the rollups themselves. Not on the Ethereum state, but on the rollup state, right? So again, Ethereum has, let's assume that Ethereum has the ZK capabilities. Instead of having all the projects that deploy their own proof system, their own verifiers that they need to maintain, let's just reuse what Ethereum already has, right? And the problem here is, okay, we want to, like the idea of this precompile is to do a recursive call, basically, of what Ethereum already does for its state transition function. The problem is the L1 execution environment is not exactly the same as an L2. So it needs to, this precompile needs to be able to handle the differences. For example, on an L2 you don't have blob carrying transactions because blobs are on the beacon chain and L2s don't have a beacon chain. Or L2s need to have a way to send messages from an L1. L1 doesn't have a concept of receiving arbitrary messages from another layer. So this is something that, when we do this recursive call to the L1 execution environment, we need to tweak a little bit to be able to support these things. Of course, if we want to have L1 to L2 messages that are used for deposits, we need to be able to also withdraw with an L2 to L1 message. We need to be able to support gas token deposits. We want to have forced transactions. And then, there are some small differences, for example, in some opcodes or some pre-deploys like Randao and Beacon's root storage that are coming from the fact that, again, the rollups don't have a beacon chain, a consensus layer attached to it. They're just attached to L1. The good news is all these problems are solvable and very easily solvable. Like I spent, the past months working on this, and there are like easy solutions, very simple solutions that minimize the diff with L1. I would love to go into the details, but I don't have the time. But what I want you to get is that this is possible, and this is easy to do. We can take inspiration from all the L2s in the way that they already implement these features. But the cool thing is now, you basically can have a rollup that just reuses what Ethereum does. But one thing that, one reason why rollups are also cool is because they allow for customization. A lot of systems, they kind of want to differentiate themselves from the other rollups or from L1 itself. And so ideally, native rollups would be able to support as much as features, as customizations as possible. And again, the good news is that this is very much possible. So it is possible to support custom sequencing. It is possible to, for example, use a centralized sequencer that does 200 milliseconds pre-confirmations. It is possible to have a separate, maybe consensus, a separate sequencing layer with, let's say, Tendermint type of consensus with your own token for staking. It is possible to be a base rollup. It is possible to do some sort of proof of governance where there is a DAO rotating the sequencer, for example. This is all supported. It is easy to support custom gas tokens with native rollups as well. Like, for example, there is this chain that is planning to use a yield-bearing stablecoin as the gas token, which is pretty cool, and it's also very easy to use to implement this with native rollups. It is possible to have custom ways to collect the fees. So all these rollups, they want to, of course, make a profit. They want to collect the fees. And in Ethereum itself, the base fee is burned. But turns out that even if you do a recursive call to Ethereum itself, which again by default burns the base fee, there is a way to collect it in a very simple way. And again, I would love to go into the details, but I don't have the time. You could have custom bridging strategies, like Linea wants to implement native yield inside their canonical bridge. This is also very easily supported. And you could have custom governance with a DAO for upgrades or whatever you want. So this is currently what I'm working on. I have this MD book where I'm collecting all the thoughts, how to implement this, all the benefits, all the challenges. and I have a draft already for a spec. I will very soon hopefully publish an EAP. And yeah, that's all I have. Thank you.